Hello everyone, Johnson here, and welcome to this quick video on provide access to Key Vault with an Azure RBAC. In my previous video, I demonstrated how to access a secret stored in an Azure Key Vault from an Azure virtual machine by using managed identity. In that video, I had an application running on an Azure virtual machine, and this application needs to access an SQL Server database running at somewhere. I stored the database connection string to an Azure Key Vault as a secret. Then I assigned a managed identity to the virtual machine and created an access policy in the Key Vault to allow my virtual machine's identity to access the secret. And finally, my application running on this virtual machine retrieved the connection string from the Key Vault, and I could use the connection string to access my database securely. Now let's take a step forward. Imagine that we have another application which runs on another Azure virtual machine. This application also has an SQL Server database as its backend database. Again, we will need to store the database connection string at somewhere. Given that we have already created a Key Vault, it makes perfect sense to store this string as another secret in the same Key Vault. And then we can assign a managed identity to the virtual machine and create a new access policy to allow this identity to access our Key Vault, just like we did for the first virtual machine. The second application could then leverage the virtual machine's managed identity to retrieve the connection string and use it to access its own backend database. But this approach has a caveat. The Key Vault access policies apply to the entire Key Vault, and they don't have the granularity to assign permissions to each secret. So in this scenario, both of my two applications will not only be able to retrieve its own secret, but also have access to all other secrets and use those secrets to access other applications' backend database. If this is what you want, then that's great. But if it is not, how can we solve this problem? Well, we have two solutions. The first solution is to create a dedicated Key Vault for each application and store the relevant secrets separately. We could then create an access policy in each Key Vault and assign access permissions to the relevant application or virtual machines. With this setup, each application will only have access to its own secret, and then use those secrets to access the relevant backend database. This solution is not perfect, but it works. The downside is that you will need to manage more than one Key Vault. So can we avoid this unnecessary management overhead? The answer is yes, and the solution is Azure Role-Based Access Control, or RBAC. This is a feature currently in preview. Now, this feature allows us to create role assignment not only at the Key Vault level, but also at each individual secret level. In this scenario, both secrets are stored in the same Key Vault. Then, virtual machine 1 will be assigned access to secret 1 only. And likewise, virtual machine 2 will be assigned access to secret 2 only. This means that application 1 and 2 could only retrieve their own secret and then use their own secret to access their backend database. Okay, that's a theory. Now let's jump to Azure Portal to see how it works. Here from the Azure Portal, if I go to the Key Vaults and then go to the new Key Vault I have already created and go to the access policies under the settings sections, here you can see that the permission model for this vault is configured to Azure Role-Based Access Control, which is still in preview at this stage. If you want to use the access policy permission mode, you can select this option and then save. But you cannot use both of them for the same Key Vault. In this vault, I have two secrets. If I drill down to the first secret for VM01 and select the current version, here you can see the secret value is that this is the secret for VM01. And similarly, if I go back to the Key Vault and select the second secret for VM02 and Going to the current version, and you can see that the secret value is this is the secret for VM02. Now I have also created two virtual machines, virtual machine O1 and virtual machine O2 with system assigned managed identity. You can see here that under the identity management page, you can see that VM01 has the system assigned identity status on. And if I go to VM02, and you can see that VM02 has managed identity assigned as well. To assign permissions with RBAC, let's jump back to Key Vault and then select Access Control IAM. And here you can add role assignment to the virtual machines at the Key Vault level, just like how you add role assignment to a normal Azure user. But this is not what we want today. So I will go to Secrets and select Secret for VM01. And under here, I'm gonna select Access Control IAM and add role assignment from here. The virtual machine will only need to read this secret, so I will choose Key Vault secret user as the role. Under assign access to, we can assign the role to a user, a group, or a service principal. And we can also assign it to a system assigned managed identity. At the bottom of the list, you can see virtual machine, which is what we want to assign to for this exercise. From the virtual machine list, I'm gonna select virtual machine 1 and click Save. Now let's go back to the second secret and do the same role assignment. But at this time, we assign the Key Vault secret user to VM02. So we select Key Vault secrets user and then assign access to virtual machine. And then from here, we select VM02 and save. Okay, so now we have both virtual machines assigned to their own secrets. At this point, the application running inside VM01 should be able to retrieve the first secret in our Key Vault, but not the second secret. And for VM02, it's pretty much the same. It can only access to the second secret, but not the first secret. To verify this, I have connected to both virtual machines via SSH and have installed PowerShell core and Azure PowerShell module. So I can run PowerShell by typing pwsh, and from the PowerShell prompt, I can run the Azure PowerShell commandlets. To access the secret stored in our Azure Key Vault, firstly, we will need to acquire the system assigned identity by connecting to Azure with managed identity. Here I use the dash identity as the parameter for the command connect-az account. This parameter tells the command to connect to Azure using the identity assigned to this virtual machine instead of asking for a credential. As you can see from here that I logged into Azure with this MSI account, which is a short name for Managed Service Identity, and I did not provide any credentials or passwords at all. Now we should be able to get the connection string from the Key Vault. Let's use the Azure PowerShell commandlet get-az key vault secret to fetch the first secret object and store it to a variable. Now this secret object has already been stored in this secret variable. The secret value property of this object is an encrypted secure string, so we will use the PowerShell command convert from secret string to convert it to a plain text string. Secret dot secret value, and then we use the convert from secure string and as plain text, and that should give us the secret value. And here we go. We have successfully retrieved the first secret stored in the Key Vault from the virtual machine VM01. But if we try to retrieve the second secret, let's do that with the same command. If we do that, and in the field, the operation returned a forbidden status code, which is exactly we expected. So this is VM01. Let's verify this on VM02 as well. So here's the VM02 console. Let's run PowerShell. And we use connect-az account with identity to acquire the managed identity. Here we go, we connected to the Azure account with the system assigned managed identity. Then let's use Azure PowerShell command get-az key vault secret to fetch the second secret object and store it to a variable. And again, the secret value is encrypted, and let's decrypt it with PowerShell command convert from secure string. As you can see that we have successfully retrieved the second secret stored in the key vault from this virtual machine, VM02. Similarly, if we try to retrieve the first secret from VM02, so let's do that again. So let's just do the secret for VM01. And it also failed, and the operation returned a forbidden status code, which means that this virtual machine doesn't have the permission to access the secret. All right, thank you for your watching. If this video is useful, please give it a like, subscribe, comments, and share. That's it. Until next time, take care.